Great, thank you for inviting me. Some of you noticed I came in a little bit late. I was phoned at precisely 7 o'clock by the BBC saying that they'd like to know what my frank and truthful opinion was on the appointment of Robert F. Kennedy to head Health and Human Services. To which I said, well, if you really want a truthful opinion, can you just wait till I leave the country? So, malaria. You had a fantastic description of where vaccines are by Ashley. I'm going to pick up on that and talk not about RTSS, but new malaria vaccines, one of which you've heard has been licensed and rolled out in the last year, and it's very exciting, and we think will have really big impact. But also about new vaccines coming along, which are equally exciting. And I genuinely think that in the next 3 or 4 years, we will have several vaccines in combination that will have very meaningful impact. So let's start with R21. Way back, around about 2010, we took a hard look at RTSS, which was then the leading malaria vaccine, and realized that about 90% of it is hepatitis B, and about 10% malaria. And tried a few things to see if we could change that ratio. And by using a new methylotropic yeast with a strong promoter for the transgene, managed to make a particle which is covered in the malaria antigen, the circumsporozoite protein. So that looked immediately as if it might be promising. In mice, that was confirmed. We took it forward into clinical testing fairly quickly in our own tiny manufacturing facility in Oxford. And today, it is not only approved by the WHO and being rolled out in many countries in Africa, but we have excellent data showing that over 4 years in a phase 2 trial and over 3 years in a phase 3 trial, we're seeing higher efficacy than with any previous vaccine. So RTSS around about 50% in a year, we're around about the 75% mark without seasonal administration, which is good if you have a not durable vaccine. The whole point of increasing the density of the antigen on the nanoparticle surface is to increase the avidity of the antibody responses that you generate. That seems to be working, and to increase durability to the duration that you see with other non-malaria vaccines. So that's very exciting. Look out for those data. Secondly, the first vaccines that were tried and people thought would be logical to deploy are blood stage vaccines. And there's been extraordinary progress just in the last 6 to 12 months with results from my colleagues' lab, Simon Draper's, not ours, but in Oxford, and showing high efficacy reported in Rwanda at the MEME meeting just some months ago with RH5, a new blood stage vaccine that is remarkably conserved and protective. And look out for those data. They haven't been published yet, but they are really exciting. And it's very important that we have an anti-disease vaccine slowing down parasite replication in the blood and not just antisporozoite vaccines. And I think that the combination of those two, R21 and RH5, which are in trials in children in Burkina Faso, led by Professor Tinto as we speak, will be the key tool in the next few years with vaccination to make a real impact on disease. And I'm not talking about 50, 60, 70%. I think we're up in the 90% range if you do the calculations of what's going on biologically, but wait to see. It won't take very long. So that's the second advance. The third one hasn't happened yet, but given the pace of development in malaria vaccines and the fact that suddenly we have credibility because we academics can license vaccines, this is going to move very fast. And that is adding a transmission blocking component, a third malaria vaccine, into the mix. Because you want to control malaria transmission. The principle has been proven by Patrick Duffy and many other people, and Patrick's vaccine is one of the several that is being mixed with R21 right now to see how that will perform in clinical trials, I think first in Sierra Leone in the coming months. So if you put all those three together and do even very simple calculations of what should emerge, it looks really exciting. The problem, as Ashley mentioned briefly, is you've got to get somebody to manufacture these. And we have been extraordinarily lucky in getting in partnership with literally the world's biggest vaccine manufacturer. They're not in Europe, they're not in the Americas, they're in Pune, in India. They supply most of the vaccines to Africa. And Dr. Poonawalla, who founded the company, is hugely committed to controlling malaria. You saw how quickly they were able to move, not just with COVID, but with R21. They've taken on RH5. They're taking on 3 transmission-blocking vaccines at the moment till we figure out which is the best. And what's really important are 2 things. Firstly, their cost of goods. If you manufacture at a 1 million dose scale, you're going to be looking at least tens of dollars per dose. That's too much. If you're at a 1 billion dose scale, as they did with COVID, and hopefully will do with malaria before too long, you're down to single figures, or maybe even less. The average vaccine in EPI costs cents, not dollars. You've just got to get to scale. So taking on 3 malaria vaccines isn't crazy. It increases your impact. It allows serious elimination campaigns to start in the coming years, and eradication, I believe. Of course, with all the other tools that you have heard about. So let me leave you with the thought that some of you in this room will see malaria eradicated. I don't know about people of my generation, but we live in hope. But we have tools that we didn't have before. We've figured out a lot about how to vaccinate against this parasite. We have fantastic complementary tools which must be used in those elimination campaigns. And things are moving fast. Thank you.